Now this is a simply spotted beam. We have a pin spot here on the left at A, and we have a roller spot here on the right at C, and on top of this beam we have an applied force or a load of 10 kilonewtons applied at B, where B distance from A is 2 meters and distance of B from C is 4 meters. Okay, so we are going to use the equation of equilibrium in order to solve this problem, which is to find the reaction of the beam. The two equations of equilibrium, the three equations of equilibrium, is sigma m, or the sum of all moment forces, equal to 0, and then the sum of all vertical forces equal to 0, and the sum of all horizontal forces equals to 0. Okay, so those are the three equilibrium equations. Now if you look at support A is actually a pin support, so it will have two reactions. One is vertical reaction, the other one is horizontal reaction. We name the vertical reaction VA and name the horizontal reaction HA. Okay, and then on the roller spot we only have one vertical reaction, which we name VC. Okay, so one thing we need to know is that the force, applied force, is vertical. It means that there is no horizontal force. If there is no horizontal force, there is no horizontal reaction. All the loads that we are using here are all vertical loads, so there must be an equal and opposite force for every applied force. So since there are no horizontal forces, there will be no horizontal reaction to resist it. Okay, so that means that in this equation here we do not have to use the sum of all horizontal forces equal to 0, because the sum is already 0. Yeah, so we will use both the sum of all the moment forces and the sum of all horizontal forces equal to 0. Okay, so to begin with, we use the sum of all moment forces equals to 0. Okay, but first we have to determine that the sign convention. Yeah, the sign convention means that either clockwise rotation or anti-clockwise rotation will be positive. So in this case, normally I use a clockwise rotation is positive, and I put a sign there just to remind me. Okay, and the next thing is that we have to determine what is the center of rotation. Yeah, the center of rotation can either be on A or C, so make sure it's at one of the supports. Yeah, normally I will use the right support, the center of rotation, so just put a note there. This is center of rotation. Right, so the center of rotation will be at support C. So after establishing the center of rotation, now the moment forces are all the forces here. There are three forces here. One is the reaction VA, the other one is the applied load 10 kilonewton, the other one is the reaction VC. Okay, so we take each one of the reaction or the forces, each one of the forces multiplied by its distance from the center of rotation, and that is equal to the moment force. So we take from the left. I normally take from the left to the right, yeah, left to the right. So the first force on the left is VA, and the distance of VA from C is 2 plus 4, which is 6 meters, yeah, 6 meters. So I put in here VA times 6. Okay, now VA, okay, is the first force. The second force is 10 kilonewtons, yeah. So 10 kilonewtons, it is the distance of 4 meters from C, which is center of rotation. So then the next one will be 10 meters times 4. 4 is the distance from the center of rotation, and these distances are called lever arm, yeah. The next force, if I travel from left to right, next force is VC, no other forces there, VC, and VC is actually right at center of rotation, so that means there is no distance. VC have no distance from C, it's exactly there, so distance equal to 0 actually. So I put VC times 0. Okay, so those are the three forces there. Now I apply the sign convention. The sign convention is clockwise is positive, and I look at this. VA rotate around C. This is right. This is the line of action, and this is the distance. It is rotating around C in a clockwise manner, because it's going up. Okay, so it means I put here positive. Okay, and then for the load 10 kilonewton, it is actually rotating around C in an anti-clockwise manner, because this is actually going down. So you will rotate around C in anti-clockwise manner. That means if you use this sign convention, anti-clockwise is negative. Alright, so for VC, because it is right at C, center rotation, we don't need to give any sign convention there. We just put plus or minus, yeah. Okay, and the whole thing must be equal to 0. Why? Well, because this is what it says. In order for equilibrium, that means stability, sigma m equals to 0. So this equation here will be equal to 0. So therefore, we can now simplify the equation. So this is 6 VA equals to 40. Yeah, so therefore VA equals to 40 over 6 kilonewton, and that is the first answer. Okay, now to determine VC, we can use the second equation there, which is sigma Fy equals to 0. Sum of all vertical forces equals to 0. So let's just do that here. Sum of all vertical forces equals to 0. Yeah, put a colon there. Now we use a sign convention that positive is all forces which are going up. All forces going up is positive. Okay, so if we go from left to right, the first force is VA, and VA is actually going up. So therefore, we have VA. Okay, and then we have this 10 kilonewton force going down. So we put in 10 kilonewton there, and then we have VC going up. So we put VC there. Now, for forces, sum of vertical forces, we don't need to multiply by distance, because it is not a moment force. It's just a force. If it's a moment force like this one, we have to multiply the force times the distance to the center of rotation. Yeah. So in this case, we don't multiply by any distance. So we see here, as I mentioned just now, VA going up. So using the sign convention is positive. So let's put positive there. Now 10 kilonewton is going down. That means it is negative. So put negative there. And VC is going up. So that means it is positive. So put positive there. And the sum of all this must be equal to 0, because that's what the equation says. Yeah, sigma Fy equals to 0. Sum of all vertical forces equals to 0. Alright? So since we want to find out what VC is, we can rearrange this equation. Yeah, VC equals to 10 minus VA. Okay? So VA we already find from this one. We already determined what VA is. So just substitute into that equation there. 10 minus 40 over 6, which is equal to 20 over 6 kilonewton. And that is the second equation. Now we can check whether that is true or not. If we add VA and VC, it should be equal to 10 kilonewton, which is the load going down. Yeah, all the loads, all the reactions going up must equal to the load going down. So VA is 40 over 6, VC is 20 over 6. So VA plus VC equals to 40 over 6 plus 20 over 6, and that's 60 over 6, and that is equals to 10 kilonewton. Yeah, so this 10 kilonewton is exactly the same as the load going down.